And on page 620, which is a blank page, I'd like you to write down these strategies. Okay? So far, the most important strategy that we've probably done already is these two. Those two sort of go together. If you can change trig functions to sine and cosine, and then write both sides as a single fraction after doing that, a bunch of proofs become super easy. In fact, on that proof page that I gave you, probably the first 20, you use that strategy, you'll solve every single one of them. That doesn't mean that that strategy is always the best strategy. And sometimes there's faster strategies. And so I've included some other things here that are going to help us. And then we'll look at some proofs where we can use some more of these advanced strategies. Okay, I'm going to put a number 2 beside this one and this one because they're basically the same, using a Pythagorean identity, or if you see a 1, because sine squared plus cos squared equals 1, and tan squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. We've seen those ones already as well. The red ones with the star are the advanced strategy that we're going to learn today. Sometimes you need to factor, sometimes you need to build the other side. And I'm just going to put a check mark beside this one. This one, always be aware of your goal, always be aware of the other side. There was a proof that we did earlier that had tangent on one side and cotangent on the other. We did it by changing to sine and cos, but in that example that we did with tangent on one side and cotangent on the other, there was a shortcut because you can change tangent to cotangent. And so being aware of what's on the other side can sometimes help you decide what would be a best strategy to use. Now we've done example 1 already. What I want to do is revisit part B and look how factoring might help you with part B. So in part B, the way that we solved this or proved this last time is we noticed, we did the strategy of looking on both sides of the equation and being aware of the other side, and said one side is in cotangent, the other side has cotangent and cosecant squared. And because we have memorized all of the identities on our formula sheet, okay, or have planned to memorize them, because they're on your formula sheet, sometimes you think, oh, they're on my formula sheet, I don't need to memorize them. I'm telling you, you still need to memorize them mostly. You can have them mostly memorized and then have your formula sheet just to check. But you need to have in an identity the idea that cosecant squared is related to cotangent to help you. Otherwise, you won't see the strategy that's the shortest. So last time we changed the cosecant squared to cotangent squared plus 1. This time, I'm going to factor out a cotangent. Do you see how there's a cotangent in common? And so I could factor it out. And then, if we look at this formula right here, cotangent squared plus 1 equals cosecant squared. Can you see that you could easily move the 1 over to the other side and get cosecant squared minus 1? If you can see that, we have cosecant squared theta minus 1 here. That means we can directly change that to cotangent squared theta. And we get we finish our proof. So introducing the idea of factoring makes this proof a little bit different than how we proved it last time. But sometimes that idea of factoring can be really helpful. Okay, I've added a part C to this one. Prove tan to the 4 minus secant to the 4 equals negative tan squared minus secant squared. In our strategies, we had factoring and then in brackets, difference of squares. The left-hand side is a difference of squares. So when you see a difference of squares, it can factor. The other thing, being aware of the other side, I see everything in this proof is with tangent and secant, and because I have an identity that's tangent squared plus 1 equals secant squared, I probably want to keep it with tan and secant. So initially, that's why I am not changing it to sine and cos, because I'm aware of the other side, and there's probably going to be a shortcut that's going to help me. So factoring this, well, I would have tan squared and tan squared. One would be plus, one would be minus, secant squared and secant squared. Now take a look at your tan squared plus 1 equals secant squared formula. Okay, I'll write it up here off to the side so we can look. Tan squared theta plus 1 equals secant squared theta. That's on our formula sheet. Can you rearrange this formula to ever get tan squared plus secant squared? Can you rearrange this formula to ever get tan squared minus secant squared? Can you see that you could rearrange this formula to get the second one, but you couldn't rearrange the formula to get the first one? If I rearrange the formula to get the second one, what would be on the other side? A minus 1. And then if you multiply this minus 1 through, you get negative tan squared minus secant squared. Now, if this jump is too much for you, you could say, I know that tan squared is secant squared minus 1. So I could replace the tan squared with secant squared minus 1. And then you could say, I could see that my secant squareds will subtract and get rid of each other. I'm left with just minus 1. And then I could distribute to get this as well. So here in this example, we see that factoring a difference of squares is what's going to help us.